5 years ago, on August 12, 2018, the Parker Solar Probe launched from Cape Canaveral and hurtled toward the Sun to travel closer to our star than we have ever been before. Ever since, the plucky little spacecraft has been reshaping what we know about stars, about our own Sun, and about how stars affect the solar systems around them. It has repeatedly broken its own records for the fastest human-made object. In 2024, it will reach a top speed of about 700,000 kilometers per hour. That is fast enough to travel from New York to Tokyo in less than 1 minute. In December 2021, the Parker probe reached the atmosphere of the Sun. Since then, it's been looping around the Sun, drawing closer each time and sending back tons of data about everything it encounters. Every close encounter opens up new opportunities to understand better how the Sun works and how it affects us here on Earth and beyond. Let us see a few of its findings so far. First one, magnetic funnels litter the Sun's surface. Among the first findings from the probe was strange flips or switchbacks in the magnetic field as the spacecraft approached the Sun. According to NASA, during Parker Solar Probe's sixth flyby of the Sun, it found that these flips aligned with magnetic funnels in the solar surface. These funnels emerge from between structures called supergranules, giant bubbles on the Sun in which hot plasma from the solar interior rises up, spreads out across the surface, cools and then sinks back down. It is possible that these funnels hold the key to understanding why the corona of the Sun is so much hotter than the surface, a mystery that has plagued science for more than half a century. Next one, the Sun's corona is wrinkly. The surface of the corona isn't shaped like a smooth ball but contains spikes and valleys that wrinkle the surface. These turned out to be coronal streamers, giant plumes of solar material rising through the Sun's atmosphere. The results, NASA said, are reshaping what we know about the Sun's atmosphere and how it transforms into the solar wind. Next one, there are way more energetic particles flying off the Sun than we realized. Particles are flung off the surface of the Sun at extraordinary speeds. We only rarely get them on Earth, but Parker probe's instruments have picked up huge amounts of these particles. Not only are they much more numerous than we realized, but they come in many different types and they often take very circuitous routes as they are captured by the flipping magnetic fields. Next one, Venus has a very long plasma tail. The Parker probe uses Venus to round the corner for its trips around the Sun, so it is taken groundbreaking data on Venus too. It has imaged the dust ring around Venus, made measurements of the radio waves in the Venus atmosphere, and helped scientists better understand the geology and mineralogy of Venus. It has also studied the comet-like tail of plasma that trails Venus and found it's huge, equivalent to the radius of the planet. Parker probe also took the first ever images of Venus's surface in visible wavelengths, that is, capturing what we would be able to see if humans approached Venus. Next one, about what powers comets and where they came from. From its position in space, Parker probe had a chance to catch close-ups of a comet passing by and is shedding light on the origins of the Gemini meteor shower which light up the skies above Earth every winter.